Hi everyone, and welcome to Containers 101 online meetup. In today's meetup, we will continue demonstrating how to build and run microservices applications. Today we will focus predominantly on two main items. The first one will be on-build triggers. We can add on-build triggers to Dockerfile. We will see how we do it, how it works. Then we will actually start looking into more than a single microservice. We will do an introduction to Docker Compose. We will not cover all of Docker Compose today. It will take more than a single meetup to cover Docker Compose. But today, we'll just see the basic of Docker Compose and how we can spin up more than a single container together. Okay, I assume most of you have been with us on the previous meetups or have seen the recordings, but for those who this is the first time, welcome. This meetup is a series of 30 minutes webinars plus more or less 10 minutes for question and answer. While we do have some slides to set the context, most of the meetup is hands-on in the terminal. We're going to see live demos of how we're using the Docker technology. The sessions are recorded. In fact, you can already see the previous sessions on vimeo.com/channels/containers101. We also highly encourage you to suggest topics that you would like us to talk about in future meetups, or maybe even position yourself as speakers if you would like to talk here. Few words about myself. So my name is Raziel Tabib. I'm a developer at heart. I'm based out of here in the Silicon Valley since 2008. I'm also the founder and CEO of Codefresh, which is sponsoring this meetup, and also member of the Node.js Foundation. Few words about Codefresh. Codefresh is a Docker platform for dev team. It basically helps dev team with building, running, and testing Docker images very effectively. Will allow you to instantly spin up environment, whether it's single Docker or composition of Dockers, on every commit or branch or pull request. We've also been chosen to be a new innovator sponsor of the DockerCon event coming up in Europe. And lastly, if you're passionate about Docker technology, we're hiring, we're growing, so please email us at joinus@codefresh.io. Okay, some terminology. We're going to be using intensively these terms. I assume some of you are already familiar with them, but for those who are new to Docker, I will breeze through these terms. Dockerfile is basically a recipe that instructs the Docker daemon how to build a Docker image. Docker images are basically the blueprints of our applications, and Docker containers are running instances of these Docker images. Docker daemon, this is what is doing the heavy lifting of building and running Docker containers. Docker client is what we have on our local machine that actually connects and works with a daemon. And Docker Hub, it's a registry of Docker images. Short recap of what we did in the previous meetups. So in the first meetups, we got a very brief introduction to Docker search, Docker run, and Docker commit command. And basically what we did, we've learned how to create a Docker image using Docker commit. So the way we did it, we run a Docker container of Ubuntu. Inside these containers, we have manually installed Node.js. We've manually created an Express microservice. Then we stepped out of this container, and using the Docker commit command, we created a Docker image. In the second meetup, we've actually learned about a different approach of how to create a Docker image. We created a Docker image using a Docker file. We've also learned about the caching and layering mechanism of Docker and how to optimize our Docker file and layers so the build process will be much faster. Again, the recording of these meetups are available on vimeo.com/channels/containers101. What we will be seeing today, as mentioned earlier, we will build again a base Docker image with Ubuntu and Node.js. But on top of Ubuntu and Node.js installation, we will add an on-build triggers. And on-build triggers means that these triggers are going to be executed later on by the Docker daemon in a downstream build, which means that after we create this image with these triggers, we will create a simple microservice, and then we will write a Docker file for this microservice, which will indicate in the first command from the base image that we created. When the Docker daemon will see that line and it will see that the base image have triggers, it will execute these triggers here as part of building a Docker image for a microservice. Again, I will elaborate about it a little bit more in a few slides, and we're going to see a live demo of it. In the last part of the meetup today, again, we will get a brief introduction to Docker Compose. So here, before jumping into the demo, a few more words about OnBuild. This is the documentation of OnBuild from the Docker documentation. As you can see again, OnBuild is basically triggers that the daemon will be executed in a downstream build. And we can look at them as command that will be added to the downstream build right after the from. Look at it in a visual way. If we created this base image and we've added these triggers here as part of this image, later on when we create a microservice, when we create a Docker file, that the from command is pointing to the image with a trigger. When the Docker daemon will be executing this Docker file, it will actually execute a trigger as if this trigger had been added just after the from command. Okay, so let's see how it works. Let me jump to the console. And first, let's see what we have installed here. So I can do Docker minus version, and we can see that we're running Docker version 1.81. Let's look at which host we have installed. So we do that by running Docker machine ls. So in fact, we have two hosts running on this machine, and we're going to be working with the meetup host for this meetup. Let's see what images we have. And in fact, we already have two images on our host. One of them is a Mongo image that is running MongoDB, and we will be using this image later on when we will demonstrate composition, how we're running a composition with Docker Compose. But I've also created an image up front, which is a Node.js based image that includes only Ubuntu and Node.js. We're going to look into the Docker file that I used in a second. Let's just run this image and see that we have a Node.js installed properly on that image. We can do that by running Docker run Node.js base attack 0.1, and we're going to run node -v, and we can see that yes, we have the latest version of Node.js installed on this Docker. This may be a good time to mention, actually, there is in the past month Node.js version 4 has been released, which is a great news, as this is the first version when IOJS and Node.js coming together into one stream, which makes our life much easier. Okay, so let's look at the Docker file that I've used to create this base image. We'll open it with VI. And in fact, what we can see here is that the from is from Ubuntu, and it specified myself as the maintainer. And after that, there are all of these set of commands that what these commands do, they basically install Node.js. After that, we're creating a folder in this image for our source code, and we do specify that the default command when we're running a container out of this image will be npm start. Okay, that's what we have here. Again, we covered it in previous meetup. Let's see now how we add triggers to this Docker file. So let's go down here and let's add 3 triggers. The first of them, it always starts with onBuild. Then the command that we want to be executed when these triggers is called. So onBuild, and the first thing you want to do is copy the package.json file we have to the current directory. Then after copying the package.json, we want to run npm install. And then lastly, we want to copy the rest of our microservice files to the local directory. Now, some of you may wonder, we could have actually just have 2 commands here, copy all the files and then run npm install. Why we break it into just copying the package.json, running npm install, and then copy the rest of the files? The reasoning behind it, and again, we have covered it in the previous meetup, but I will just briefly mention it. The reasoning behind it is we wanted to optimize again the build process and leverage the layering and caching mechanism of Docker daemon. And as we built it this way, what it means is that we will not run npm install. It will be taken from the cache unless the package.json has changed. If our source code file have changed, this is the last layer, so only this layer will be built and not running npm install. If we would have copied all the file before, then when the one of the file has changed, then the layer of copying the file would have changed, and then we would have run npm install for each and every change which is redundant. We basically want to run npm install only if the package.json file has changed. Again, this is, I might have breezed through it now, but we covered it in more details in the previous meetup. Okay, so we added a trigger. Now let's save it, and then let's rebuild our Docker based image, but this time with the trigger. So we'll do Docker build. We'll tag it Node.js base and 0.2, and we're passing the current directory as the context. As we're running it, we can in fact see that all the previous layer has been cached because we haven't changed anything in the installation of Node.js. The only 3 layers that has been added to the Node.js base image are the triggers that we've just added. So in step 10, 11, and 12, we can see 3 triggers that has been added to the image. Okay, let's now see how we can actually create a simple microservice and create a Docker file for this microservice that will call these triggers, that will actually make these triggers to be executed. So we're going to use Express to very fast create a microservice locally. So we'll do Express microservice, and that will create a folder microservice with a Express code in it. So let's step into this directory. This is the code for Express microservice. Now, what we will do here, let's write the Docker file for this to package this microservice in an image. Now, since we have a base image with all of these triggers, the Docker file that is required here is very simple. All we need to do is just say from, and then we call, we'll specify the Node.js base with 0.2. That's the one that we created, and then that's it. Unlike in the previous meetup, when we have wrote all of these commands, all of these triggers as part of the Docker file that belong to this repo, the triggers allows us to specify in one place the commands that we want to be executed in each and every microservice that we have in our application. And then it's sort of, we can think about it as inheriting. So all the other microservices, if they will start by from Node.js base 0.2, it will cause the triggers that we specified them to be executed identically on each one of these at each part at each um, build process of these Docker images. Okay, let's step out and then let's see it in action. Okay, so I'll do now Docker build, and we want to build this microservice, and we're going to call it microservice 0.1, and we'll pass it the current directory. And then as we run it, what we can see is that immediately the Docker daemon is executing the 3 triggers that we have added in the Node.js based image. So it executed the first one and copied the package JSON, then it executed the second one and run npm install, and it then executed the third one, which basically copied the rest of the file. So that's how simple and fast it was to basically create a base image and then call these triggers each time we create a new microservice. Now let's see, we can do Docker images. We can in fact see that we have our image here. Let's see that it's working. We'll do Docker run. Let's run it in the background, and then let's map the port 3000. We run in microservice 0.1. Let me see that okay, looks like I wrote it right. Let's run it. Okay, we have the container running. We can run docker ps, and we can see that we have this container running. Now let's access this container in the browser and see that it's running properly. To do that, let's find out what is the IP that can help us access the containers inside the meetup host. So to do that, we'll do docker machine IP, and then we'll specify the host in which the Docker container is running. In our case is meetup, and we can get the IP. So let's copy paste the IP from here. Let's go to our browser. Let's paste it here with port 3000, and here we go. We have the Express microservice up and running. Okay, so this is the first thing we wanted to do in this meetup. Let's go back to the slides and let's see what we're doing next. So next, what I would like to do is actually demonstrate a composition of more than one container. So for that, we have created a simple application, simple mini microservice application, if you may say so, that save contacts, that allows you to save contacts in a database. And basically, if we double click in on this application, we can actually see that there are 2 containers that are required to run as part of this application. One of them is a Node.js microservice, and the other one is the MongoDB database. Now, as the first step, what we will do is we will actually manually run each and every one of these containers. We will first run the MongoDB container, then we will run the Node.js container, and we will pass an environment variable to these containers that will allow this microservice to connect to the MongoDB. After we do it, we can actually see that there is a simpler way to do it by writing a simple Docker Compose YAML file, and this Docker Compose YAML file helps us in modeling our application, defining all the microservices, all the components of our application, and define the links between them. And once we define and model our application in a Docker Compose YAML file, by simply running Docker Compose app, we can spin up this composition and have it up and running. So again, first we're going to do it manually. We're going to see how we're doing it, and second, we will see how we can do it using Docker Compose. Okay, so first thing, let's go and actually see. So the repository of this application is on GitHub, and you may clone it and play with it. I will send over the link for this repo after. Let's copy the URL to this repo. Let's go back to our console. Okay, let's step out of the microservice we created. In fact, we can also stop the microservice that we run. We'll do docker stop for a9. Again, it's enough just to specify the first 3 letters of the running container to stop it. We're going to wait a few seconds for Docker to stop the running container. And now let's do git clone to get the code of our microservice that connects to the MongoDB. We have it here. Now, in a very similar way, since we want to package these microservice in a Docker image, let's step into this folder and let's create a very simple Docker file that in a very same way, all it does from Node.js base 0.2. That's it. We can step out. We can run Docker build. Let's call this the web component of our microservice. And we'll pass the current directory as the context. And again, in a very similar way as you've seen before, now the 3 triggers are being executed. And in fact, we're now building an image that will include our sample microservice application in it. So here it is, it's done. If we run Docker images, you can in fact see that we have the Docker container here, the web for our web component of our mini microservice application, and we also have Mongo, which I have pulled from Docker Hub. So let's start by running the MongoDB container. We'll do that by docker run. We'll run it in the background, -d. We'll map the port of 27017, the standard of MongoDB 017, and we'll specify the name of the image, Mongo. That's it. We'll do docker ps. We have the MongoDB running. Now let's look a little bit at the code of the microservice so we can see how it actually connects to the MongoDB. So if you go back to GitHub and we go into config and we look at the database connection string, we can see that our code is actually using a Mongo_URI environment variable if it's available. If it's not available, it's actually assumed that it has Mongo entry at the etc host of the running containers. So in our case, we're going to be just running this container by passing an environment variable. Later on, we will see that when we run it in a Docker Compose, we can actually rely on Docker Compose to have that entry in etc host, so there is no need to pass any environment variable. So again, let's go back and just use the environment variable to tell the microservice how to connect to the container. So let's do Docker machine IP again to remind us what is the IP that can be used to access containers in the meetup host. So do that. This is the IP. Okay, now let's run the Docker Docker image of web. So we'll do docker run. We'll run it -it, so we're capturing the standard input and output of the running container. We're also going to be mapping the ports 9000 to 9000. And now let's see, we're using the flag -e to pass an environment variable. We're gonna specify the name of the variable, Mongo URI, and then let's enter here MongoDB, the connection string MongoDB // then it's, I'm taking it from here, it's 192.168.99.0.101. Then the port is 27017, and we're just going to use test as a schema. So we've actually specified here the connection string, MongoDB // the URL of accessing container in our host, the port that we have exposed, which is 27017, and then a simple name, arbitrary name for the schema. Now let's specify the name of the image that we want to run, which is web 0.1, and that's it. Let's run it, and we can actually see that we have the Docker container now running. Let's check out and actually see that we have our application running, and we can save contacts in the MongoDB database. So we come in here, specifying it in this case now the port is 9000, and here we go. We have the application running. We have both the MongoDB running and the web component running. Let's test it out. Let's add here the and email, do add contacts. All works perfectly. We have our mini microservice application running. Now, as you can probably tell, we've managed to do it. You can do it, but it's not that simple, and we have to do some manual steps. Let's see how we can actually go and define how our mini microservice application, how it's being modeled, how we can configure and define the links. And once we do it one time, we can see how easy it will be to spin up a composition and spin down a composition. Okay, so let's go back here. And now what we'll do, let's step out of this container. Let's also stop the MongoDB. Stop. Again, we're going to specify the first 3 letters, IFA, so that we have no Docker container now running. And what we will do now, let's start writing our first Docker Compose YAML file. So we'll do that vi docker compose YAML. And here we'll start defining the components that we have in our microservice. So the first one, we call it web. And we could have basically say here that we want to use image web 0.1, and that would have worked. But since we have a Docker file in the current directory, and we want this image, whenever we change the code, to be rebuilt, we don't want to use a static binding of a specific image to our composition. Rather than specifying and calling out the build, the Docker build, we can actually tell Docker Compose build. And what Docker Compose will do, it will look for a Docker file, and it will create this image as part of the Docker Compose app. So we'll do build, then let's go and specify the ports. And then let's go now and specify the links. This is the interesting parts, how it makes it easy. We can call our link here Mongo. And then if we just write it this way, we don't use the name of the component and an alias. So Docker Compose will use Mongo as both the alias that and the entry at the etc host that we talked about earlier, as well as that's the name of the component here. So we'll define this component here, Mongo. Here we do gonna link into we're gonna bind it into an image. So we're gonna use the Mongo latest, and ports we're gonna have here again 27017 map to 27017. That's it. This is how simple it is. Basically what we have here, we have two components. The web component, we're going to tell Docker Compose to build the image each time our code change to when it's running, to map port 9000 to 9000, and we're going to tell them when you run this container, make sure that there is an entry at the etc host called Mongo, and in that entry put the IP and how to access the Mongo component. Then we specify the Mongo, we tell it to run with the Mongo image, MongoDB latest image, and export the port 27017. Okay, let's now step out of it, and then let's see how it's working. We do Docker compose app, and now in fact we can see that the first thing that the Docker compose doing is, as we specify build, it's rebuilding a Docker image for our service. And the way it does it, it's again, it's running the Docker file, so we can see the 3 triggers that we put in the Node.js based image being executed now as part of building that image. And as it completed creating that image, it run that image, it's also run the MongoDB image, it's run our web component, and let's see if it actually put in all the right data. So we have our applications running, and we have the web component connected well to the MongoDB component. So let's go back to the browser. Let's refresh. In fact, it's new here, and in fact we can see that our application is running. We can try this again, and then yes, everything is running properly. We can add more. We can refresh. We can see actually that this data is being saved in the database. So again, this is pretty simple. This is how powerful is Docker Compose. In fact, if we're going again and just looking at the code before we're stepping out, so when we run it with Docker Compose, actually the connection string that our web component use is the one over here. It just used Mongo as the IP, as it relied on the fact that Docker Compose will add that entry in etc host, so this will be translated into the proper IP of where we have the MongoDB running. Okay, with that saying, let me go back to the slides. Let's briefly again talk about what we covered today. So we've learned first about the on-build triggers and how to add them to our based image. Then we have built a simple microservice. We created this very simple Docker file for it that codes these triggers to be executed. And then at the last part, we've actually got some introduction to Docker Compose. One comment I want to make regarding the on-build: if your application and your microservice is just basically Node, there is no specific triggers that you want to add as part of your own microservice, then you could have basically just go and in Docker Hub, if you go there, if we look for Node, we can in fact go into the official Node images, and we can see that there are already available Node.js images with the on-build tag. And all of these images with the on-build tag basically have this trigger. So the way to use it is just to have from and include the and have the Node.js image with the onBuild tag, and that will basically brings in these triggers. We can actually look into the Docker file of this onBuild, and we can see that it has very similar triggers to the triggers that we have created earlier in this meetup. Okay. Again, thank you for attending. We will be posting the recording of this meetup on our blog and on the Vimeo channel that we have at vimeo.com channels /containers101. You may sign up on meetup.com containers101 online meetup to attend live the future meetups that we're going to have. And we also highly encourage you to attend the Docker online meetup delivered by Dockers themselves. If you have any question, don't hesitate to email me at raziel@codefresh. You may follow me on Twitter on @razieltabib or following Codefresh on @codefresh. And lastly, if you're passionate about Docker technology, we're hiring, we're growing, give us a shout and join us at Codefresh.io. Thank you all, and looking forward to see you in the next meetup.